Assalamu alaikum. In this video, we'll discuss about silvered lenses. If any one of the surfaces of a lens is silvered, then we call such lens as silvered lens. Let me show you how it appears. Suppose this is a lens. A lens is made of a transparent material bounded by one or two surfaces. So, a lens may appear like this, or you can also find lenses of this kind. This is a plano convex lens. This one is a biconvex lens, and also we come across concave lenses. Okay, here I take this biconvex lens to explain a silvered lens. Here, out of these two surfaces, we silver any one surface. Here, I take this surface, which is a silvered. Suppose this surface is silvered. Then, this lens may act as a mirror. So a silvered lens is a mirror as well as a lens. So what will happen if light falls on it? When a light fall on this kind of silvered lens, suppose this is an incident ray, it travels in this direction. After inciding, when the light incident on this silvered rare surface, it gets reflected, as it acts as a mirror. So here both the reflection and refraction takes place in this case. Okay, so we can conclude that light travels twice through this kind of a silvered lens. Okay, so what will be the power of this kind of lenses? The power of this kind of lens is the sum of power of the lens and the power of the mirror. So, power of a silvered lens is equal to power of the lens plus the power of the mirror plus the power of the lens once again, because light travels twice through this kind of a silvered lens. Okay, so we have PL twice. Now, I am going to mention the values of all these terms present in this equation. Okay, here power of the lens is nothing but the reciprocal of the focal length. We know focal length is nothing but the distance between the pole of the lens. Pole is the geometric center of a given lens. It is not drawn properly. That appears to be at the center. Okay. Now, if this is the focus of this lens, then the distance between pole and focus is referred as focal length, small f. Understand? So reciprocal of the focal length is the power of the lens. Then from this equation, Pm value. Here Pm stands for power of the mirror. Here power of the mirror is nothing but reciprocal of negative of the focal length. So minus n is used here. Yeah. By substituting these things in the above equation, see what we get. Now here I told you power of the mirror is the reciprocal of negative of the focal length of the given mirror. So for this reason, a concave mirror whose focal length is given in negative have a positive power. Okay. So here P is equal to PL plus PM plus PL. Now here I am going to substitute the values. As this lens acts as mirror, so its power is taken as reciprocal of negative of F. Then the R of L is 1 by F plus 1 by minus F. I take this within bracket plus 1 upon F. Here I use M here just to represent that. It represents just to show the difference, that it represents the focal length of the mirror. And here I use the FL to show that it represents the focal length of the given lens. So in the place of F I write L here to show the difference. Now if I add these two, I'll get 2 upon FL. As the terms present in the denominator is same, so they can be added as such. Then this become 1 upon FL. Okay, this minus n is written here. Minus 1 upon F. This is the power of the given silvered lens. Okay. If you cancel, if you want to remove this minus sign, then the equation can be written as 1 upon F equals to 1 upon Fm minus 2 upon Fl. This is the final equation. Which gives us the power of a silvered lens. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your question in the comment section. Thanks for watching.